Right, what you're looking at right now is the power supply rail on the side where my let me get this on camera. This is the output voltage. Well, there's a lot of noise on that side. Basically, you can't really trust these voltages because if I disconnect the power, that's the real voltage. So this is measuring the voltage on the output side now, but it's picking up some RF noise. Now what's happening is my choke on the oscilloscope, we're measuring the voltage across where the chip will plug in, right, between that ground that's gone through my choke that I put in and the ground associated with the ground for the chip down here, right? Oh, you can't see it now. Let me move my camera a bit. I'm trying to get this all in if I can. Sorry about my holy pants. I need to get rid of my pants actually. Put some different ones on. Okay, that's better. Right, so let's ignore the meter though, really, because it's not really relevant right now. Actually, why am I bothering with that meter right now? Let me just move it out of the way. Right. Now, my choke that I made is actually right here, right? It's hard to see right now. But connecting to the ground over here with my oscilloscope, which is clipped onto here right now. Let me move that flipping box thing. Hang on a minute. Let's move that up there somewhere. That's probably better there. Right. Right, my oscilloscope probe is connected to the power supply input of where the chip will go. The ground of the scope is connected to its common ground down here. Now notice the amount of noise on the power supply on the scope reading. It's virtually nil. Now if I move my scope ground, which is connected to the common ground for the chip, to the main input ground, you'll see one hell of a difference. Now I'm now connected to the main input ground and you'll see a hell of a lot of noise. Right, that noise is what's been snubbed and prevented from getting to this chip. Now this noise on this side is where the 555 timer is driving the MOSFETs to drive the voltage quadruple second. Now let's move the scope probe from the power supply on where the chip is to the power supply on the input. Oops, if I can get this, find somewhere to clip this on. Right, we're now measuring the power supply on the input side. Now look at the noise on there. That is a lot of noise. That is what was causing my false triggering of the TL494 IC. And that noise is still present on the other side of the choke, which means my choke works. So the choke actually is suppressing all the noise because it's on the other side of the choke. Before it's been suppressed and cancelled out, it's still there. So this is the power supply input. And now let's connect the ground of the probe. Oh, I'll pull that off now. These flipping plugs, I hate them. Back to the ground of the filtered side and also the power input to the chip, and you'll see it's silent. Silence is golden. So what does that mean? That means that when I plug my chip in, I'm not going to get false triggering anymore. So the trouble with this, I can't connect this ground of the other probe the second probe, I can't connect that to anywhere because I will cross my grounds together and I don't want that. So what I will do is I'll just connect this probe just to the positive supply input, and we'll see the difference between the two. Look at the difference there. The blue trace is the power input to the board, which shows a hell of a load of noise. The yellow trace is showing the power supply to my TL494, which is basically showing no noise at all. Yay! I'm just relieved that I got my choke right. I didn't have to. I was thinking that when I first did this, I clipped the ground all the wrong place. I thought, oh no, my choke's not working. I thought, hang on, I'm connected to the wrong grounds. So there's two grounds on here now, you see. There's effectively, well, it's the same ground, but one ground is noise cancelled, the other ground isn't. So when I'm connected to the noise cancelled, now the reason we're seeing noise on the power supply side is simply because even when this ground isn't connected to anything, and this ground is because you have to remember that the filtered ground is actually in phase with the noise, so the phase is cancelled out. So when the supply rail and the ground rail oscillate, they don't see each other because they're always out of phase with each other. So the noise is cancelled effectively. Anyway, I think it's time to celebrate. It's time for a hot cup of coffee to celebrate. Because it's cold. And I can put my chip in a while, so that'll be the next step. Will be to put my TL494 IC back in, and we'll do a test to see how it works, and if it works, and if there's something else I need to sort out, because there probably will be something. There's always something else you need to sort out, you know. I really want to see my pulse drive work, and I have no idea yet if it's going to work or not, because the high voltage side and the 64 volt side hasn't really been tested properly. So it should work though, because there's not really a lot that can go wrong on that side of it. The only thing that could need changing is my Zenas, the 47 volt dropper Zenas on the ground side and the positive side. They might need tweaking. I might have to put different values in there, but other than that I can't see a lot that really needs to be changed, because I've already worked out the driver side for the opto isolators. The biasing for, on this side is I've already worked it out on the breadboard, and that works, so that should work. But I won't see the LEDs flash until we put the chip in. And also another good sign, right, this is a good sign, is the fact that both the LEDs are not lit right now. If they were both lit right now, which is what happened previously when the chip wasn't in, it means that there's a problem. But because they're not lit right now, that is a really good sign. Anyway, I'm going to stop the stream because I want to keep this short, because I might put it on YouTube.